we're going to go ahead and get started. We're still talking about arcs. We're still talking about chords. And we're still talking about inscribed angles. Remember, an arc is just part of the circle, right? Marked by two endpoints on the circle. Chords are segments, and both endpoints just have to be on the circle. Remember, the diameter is a special chord, right? Both endpoints are on the circle, but it goes to the center. An inscribed angle also has its vertex on the circle. All these angles always have their endpoints on the circle, but an inscribed angle also has its vertex on the circle. All right, so we've got some new rules we're learning. So all of these start out the same way. They say in the same circles or in congruent circles. So they have to have the same, all the parts are congruent, okay? We're just talking about this circle. It says two minor arcs are congruent if and only if the corresponding chords are congruent. The converse is also true. So minor arc AB is congruent to minor arc CD if these segments are the same length. These segments are the chord. Stacia, will you spit your gum out, honey? All right, so this says if the measure of if segment AB is congruent to segment CD, then arc AB is congruent to arc CD. I'm kind of using my congruent symbol willy-nilly here, but anywho. So I did not state the converse, and I should have. So remember, the converse just means the opposite is true. So the opposite would be if arc AB is congruent to arc CD, then we would know that the chords are congruent. I'll probably do that. Yeah, you're right, most of that. I'll have to have other classes write it later. I forgot to type in the converse. So this is the first, this is the converse. People are still writing a little bit. Y'all done writing, Charlie? Okay. Look at this circle. It says in the same circle and congruent circles, chords that are equidistant to the center. Remember, equidistant just means the same distance, right? Equal as in equal. Equidistant to the center or centers are congruent. So if chord CD and chord EF are congruent, then they have to be the same distance from the center of the circle. So why is there a right angle there? Why are those marks perpendicular? Look at me. Remember when we talked about measuring the distance from the top of my head, Justine, everybody's looking at me? So if I want to measure the distance from my head to the ceiling, am I going to measure the distance from my head to the ceiling by the projection up there in the middle of the room? I'm not, right? It's going to be perpendicular to the ceiling, right above my head. It's got to make that right angle. So this represents the distance this chord is from the center. This represents the distance this chord is from the center. Okay? So, gotta get this thing off of here. So if the measure of BA is congruent to measure of BG, then CD is congruent to EF. So if this length and this length are the same, then these chords have to also be the same length. And the converse is that's the opposite thing, right? So if these two chords are congruent, then now we know that they are the same distance from the center of the circle. So these pictures that you see are going to be kind of your hints when you're working problems and they have diagrams that look similarly. If you're wondering what the rule is that you want to use, come back to this page and find the picture that looks like the picture in the problem. In the same circle or incongruent circle, if the diameter or radius of the circle is perpendicular to a chord. So remember, we're saying diameter or radius. This whole thing is the diameter, and the radius is part of the diameter, right? So it doesn't matter if you have the whole thing or if you just have the radius. If it's perpendicular, right, makes a right angle with this chord, this segment, these endpoints around the circle, then we know that this radius or diameter there, it is bisecting the chord. And it bisects this arc, right? So that means this and this are congruent, and that would mean this arc and this arc are congruent. Does that make sense, Dominic? All right. So if CF or BF, which is the radius, is perpendicular to DE, then we know that AD and AE are congruent, and arc DF is congruent to arc EF. And that's not the converse, so I need to write the converse. So this is the rule, this is its converse. So if we know that this arc and this arc are congruent, and they are marked by this, bisected by the radius or the diameter, now we know that this angle, all four of these angles are right angles. So the next couple of examples we're going to use the leave your foot in the door. All right. We'll see a few people writing. We'll wait another second. All right, I'll come back at the end if you need me. Just let me know. All right, so the first example, let's mark your diagram with the given information like I have. I didn't mark all of it, but I marked some of it. So ln is 24. I didn't mark that. I don't really know how to mark that one, but we know that from here to here is 24. We know that Kn is 12 and Jn is 2x minus 2, we know that NS has a measure of 9.5. So using our rules we just learned, we're going to find X first. Anybody have an idea what to do? Try?
Yeah, 9 minus 9.5. 9.0.
9.5.
2x minus 2 equals 9.5.
No?
Or that. It will plus each other. Equals 12.
2x minus 2 equals 12. Okay, Justine said 2x minus 2 equals 12. Why do you think that 2x minus 2 equals 12, Justine? I don't know.
Oh,
You're right. Well, I will tell you you're right, but we do need to know why, Jamari.
when she said equal to us?
Yep.
Yeah, because
Why are they equal? How do we know that 2x minus 2 is equal to 12? So in other words, how do we know that? Say it again.
they make a line.
That doesn't mean we can split a line not in equal parts, right? What do you think, Dominic? What were you going to say? Well, they don't tell us about the arcs, right? What is SQ? Is it a radius or a diameter by chance? Is it perpendicular to this chord by chance? What does it say here? So look at our, if it's perpendicular, yeah, if it's perpendicular to a chord, we know that it bisects the chord by 2 sector parts, and we know by now they have to be congruent parts, right? So it shows that the radius is perpendicular to the chord, so that's how we know that we can write the equation that Justine said, and she's right, but we do have to know why that is true. If the diameter radius is perpendicular to the chord, then the chord is bisected, so that's how we know that Kn is congruent to Jn, and that's how we know we can write the equation that Justine told us, that 12 equals 2x minus 2. Because those two segments of that chord are congruent. And then we just solve for x. Alright, so I'm going to add 2 to both sides, so 2x equals 14. Going to divide both sides by 2 to get x by itself. So now we know that x is 7. The other thing they ask us is for the measure of PS. So PS is from here to here. Can anybody tell me what the measure of segment PS is here? Be sure you can tell me why.
That's 9.5.
Here?
Yeah.
Yep. So how long is PS? You think 9 point, Charlene says 9.5, I'll tell you Charlene's right. How do we know it's 9.5, Charlene? No, that's not it. How do we know they're congruent? No, 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 remember you can't go by how something looks, right? So let's look over here at this one, because this has something that looks like it here, right? It says, if CD is congruent to EF, then we know that BA is congruent to BG. So if the chords are congruent, then we know that they are the same distance from the center. So this is the center. PS and NS represent the distance from the center. So how do we know that they are the same distance? Because these chords are congruent. But how do we know the chords are congruent? So we know that this one is 24 because it's a given, right? How long is KJ? How do we know it's 24? No, add what? We know because we said that these were congruent, right? So if this is 12, then this is 12. Okay. So that's why we have to know that if the chords are congruent, they're the same distance from the center. And we know these chords are congruent because they told us that LM is 24, and we figured out that KJ is 24. So now we know that PS is congruent to NS because they have to be the same distance from the center if the chords are congruent. So we're tempted to go sometimes by how things look, and sometimes, my mom used to say, actually my dad said more, it's better to be lucky than good sometimes, but we want to be good. It's okay to be a little lucky, but we want to make sure we understand the concept. We're not just eyeballing it, because eyeballing it doesn't always work. All right, let's go on to the next example. We'll go back if you need me to later. All right, make sure we're marking our diagram. I forgot to mark mine. Let's go through the given information. They tell us that QR is 20. QR has a length of 20. It tells us that SR, this whole thing here, has a length of 3x plus 2. They tell us that ZU is 12, and they tell us that ZV is 12. Okay. They want us to find X, and they want us to find the length of QU. All right, let's find X first. So X is part of SR. So what's the equation we can write to solve for X? And make sure you can explain to me why that equation would represent the situation. Corey? 3x plus 2 equals 20. That is correct. Why is that correct? So did they say anything about arcs there? If they said the two minor arcs were congruent, Corey, you'd be right. Jamari?
It's because they both touch R.
It is not because they both touch an arc.
R.
R. It's not because they both touch R. No. Sharad?
Because that QR is outside and inside.
No. Dominic? No. They could be perpendicular and then not be the same length. So let's look back at our rules. It has to do with the distance from the center of the circle, right? If the chords are congruent, then the distance from the circles are the same. If the distance from the circle are the same, then the chords are congruent. What is this? These are the distance from the circle, right? Are they congruent? They are. That's why Corey's equation is true. So if chords are the same distance from the center, then they're congruent. If they're congruent, then we can write that equation that says 20 equals 3x plus 2. It is okay to guess a little bit on this stuff, but you do need to start making sure you understand why it's true. They're not always going to be so obvious, especially on the end of course exams. So these could be perpendicular. Someone said it's because they're perpendicular. And this could be 12 and this could be 14, which would mean that these chords are not the same length, right? But since the chords are the same length and they are displayed as the distance from the chords, now we can write that equation. We're going to subtract 2 from both sides. Sharad,
Yes.
open your eyes, buddy.
They are.
They are now. Divide both sides by 3, and now we know that x is 6. Misha? Yeah. You want to go back to the standing desk? All right. Any questions on how we found x?
Yes.
Okay.
So of the it's called constant to the constant.
The x, the variable?
The 3x plus 2.
Oh, the algebraic expression?
Yes. What is that?
That was a given. They told us that SR had a length of 3x plus 2.
No, what I'm trying to talk like I'm honestly.
Okay.
So,
Are you sure?
okay, what if that is in the inside?
What if the 3x plus 2 is in the inside of the circle? It actually is in the inside of the circle. I just could not figure out a way to make it look not too cluttered and stick it in there. So this 3x plus 2 is the length of RS, or SR. That's what they tell us.
So I just,
Okay. You and I can talk about it after everyone can get some homework if you want, okay? All right, how do we find the length of QU? QU.
Do we divide it by 2?
We do. Why do we do that?
That's not the rule number 2.
Dang it. I hate it when she asks why we have to do that, right?
That's rule number 2.
Otherwise, we're just guessing, right? So remember,
We all right?
if the you are right, but you're right. Someone said the last time because they're perpendicular. So this is where that works. If they're perpendicular, if the radius is perpendicular, intersects through that chord, then it splits the chord into 2 congruent segments. So that is why the chords are perpendicular, and we're going to not write all that because we don't have time at this point, but if the chords are perpendicular to the diameter radius, they are bisected by it. So now we know, you can write this part. We know QR is congruent to RU because it's bisected by that radius. And now we know, just take the 20, because QR is 20. We know RS is 20 as well, but QR is 20. We want to know how long QU is. It's 10. You gotta go stand up by Misha. Go stand up back there, baby, before we start the next one. I know you were. And this is not you being in trouble. This is us coming up with a strategy to help you. So go back there and stand up. All right, we've done these before. We're going to do them pretty quick because they're taking a little bit longer to get through our notes. Inscribed angle, central angle. Inscribed angle is vertex. The point where the sides meet is on the circle. We know that this angle is half the measure of this arc. We call this the arc that intercepts it. The central angle, central and center. Central angle, its vertex is on the center point. This angle has the same measure of the arc that intercepts it, so the arc that it's across from. So in this example, this arc has a measure of 82. This arc intercepts a central angle and an inscribed angle, okay? Central angle equals the arc it intercepts. So this central angle is going to be 82 degrees. We worked with these in our homework yesterday, right? This inscribed angle looks like the inscribed angles we worked with yesterday. Some of the inscribed angles we're going to work with in a little bit don't look exactly like these, but these we should know at this point. What is the measure of this inscribed angle? Can you tell me, Sejal? What's the measure of this angle?
The one in red?
Mhm.
A2.
Okay, so the
No,
inscribed
A2 divided by 2.
correctamundo. So that'd be 40, yeah, 41. Alright, so this ain't, look at the circle on the right while I'm getting my act together here. Okay, look at this. This looks a little bit wonky. I highlighted or colored and the central angle is green. This is the inscribed angle. It doesn't look like the inscribed angles we're used to. All an angle has to be inscribed is have its vertex on the center. I'm sorry, on the circle. So the vertex here is on the circle, an endpoint on the circle, an endpoint on the circle. It's wonky, but it's still an inscribed angle. Central angles have the same measure. So this arc is not really across like we're thinking. Look, this angle looks like it's directly across from that arc. This one doesn't look exactly across, but it still is. It's the intercepting angle. So that angle is half of 66 or 33 degrees.
What is that number? So you said 66.
Yes, the same as the ones on your paper. All right. Anybody have questions on the inscribed versus the central angles?
Yes, so that, so from the outside goes into the small, the central.
So if the angle is on the center point,
Right.
it's going to have the same measure as the arc. If the angle is on the circle, it's really the vertex, so we're going to call it angle because I think that's what we're talking about. Then it's going to be half of that arc.
Okay.
Okay? So let's look at this example. Inscribed angle, the vertex is on the circle. Center angle, the vertex is on the center point. This is circle D, and it tells you it's circle D has a center D. So we just reviewed that these have the same measure. So the measure of arc BC is 96. So what's the measure of of angle BAC? What's the angle of measure?
48.
How'd you get 48, Sherrod?
I divided it by 2.
Yes, that's exactly what we're going to do. So if they give us the arc, we divide by 2 to get the inscribed angle.
Yeah,
If they give us the inscribed angle, we multiply by 2 to get the arc, right? All right, so let's try not to blur it out next time, though. Okay, Sherrod?
Oh, you asked? That's all.
Well, I did ask, but I want you to raise your hand to respond, okay? All right, I think we're good there. All right, so mark your diagram, like I have mine, least the 78-degree arc. It tells us that the circle is Z. It tells us that the measure of arc XY is 78 degrees. Hopefully we're noticing that both of these, so the endpoints of the angles have to be the endpoints of the arc that are intersecting it. This. So this is an inscribed angle. Its endpoints are the same as the central angle. So the measure of XWY is what? What's the measure of XWY, Landon? So remember, if you're a little confused about the angles, start at the letter and trace. XWY. XWY. Is that an inscribed or a central angle, Landon? Is the vertex on the center or on the circle? Yes, so if it's on the circle, what is it? Inscribed or central? Inscribed, which means it equals half the arc it intercepts, right? So if this arc is 78, what's the measure of the inscribed angle? Yes, 78 divided by 2, which is 39. All right, and what is the measure of angle XZY? What's the measure of angle XZY, Michaela? XZY. Very good. That's the central angle. It's the same measure as the arc that intercepts it. So that's a little bit of review, right? All right, we're going to move on to the last two examples. But first, we're going to go over a new rule. If a quadrilateral is inscribed in a circle, and all that means is that the corners are on the circle. Technically, the vertex, the vertices, which is multiple vertex, right? Those corners are on the circle. We know that its opposite angles are supplementary. Are you looking at the board, Carly? You're not. I know you're not, so I just put that. Turn your body, baby. Thank you. All right. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. What does it mean for angles to be supplementary? Molly, do you remember? Well, they're both, so B is 180 and F is 180? If you add them together, they equal 180. Very good. So opposite are B and F, C and D. So it's the measure of angle B plus the measure of angle F, it equals 180. The measure of angle C plus the measure of angle D, it equals 180. So the next rule says if an inscribed angle intercepts a semicircle, so how many degrees are in a semicircle? 180, right? 180 means from one endpoint of the diameter to the other endpoint of the diameter, right? The diameter splits the circle into two semicircles. So if an inscribed angle intercepts a semicircle, then it will equal 90 degrees. So this is an inscribed angle. I feel like this rule is a little bit redundant because we already know that this angle is going to be half of the arc that intercepts it, right? If the arc that intercepts it is 180, then this has to be 90. So, but that's all this says. Just if you see a triangle that's inscribed in the circle, that means the vertices are all on the circle, and the endpoints of this angle are actually the endpoints of the diameter. Now we know that that inscribed angle is 90 degrees, which makes sense because we already know that its arc is 180, right? So that's all we're saying there.
So it all equals 180, 90, so it seems like
this angle,
split it in half, basically.
this angle is going to be 90 degrees.
Oh.
Right?
Okay.
So this is an inscribed angle. It's inscribed because the vertex is on the circle. Its endpoints are on the circle. This one, its endpoints are also the same endpoints of the diameter, so we know the arc is 180. Half of 180 is 90. So it's not really a new concept there.
That's not it.
Okay.
Oh, no,
We'll go with that. All right. So, quadrilateral inscribed in a circle. Remember, if you're not sure, look at the picture. That one looks more like this one than any others we've done, right? So we know that if a quadrilateral is inscribed in a circle, we know its opposite angles equal what? What do its opposite angles equal? 180, right? So let's start with the measure of angle. Let's start with marking the given information. So if you have not marked, let's go to mark. Arc RQT is 228 degrees, and the measure of angle QRS is 123 degrees. We're going to find the measure of angle RQT and the measure of angle QTS. I'm going to start with this one. The measure of angle QTS. So QTS. So what is the measure of this angle? So quadrilateral, this angle and this angle would be opposite angles, right? What do we know about those two angles? Lennon? What do we know about angle QRS and angle QTS, these opposite angles? Lennon, do you know I'm talking to you? I'm asking you. Did you know I was talking to you? Okay. These two angles, opposite angles of an inscribed quadrilateral in a circle. What do we know about them? Opposite angles. They are supplementary, which means if we add them together, they're going to equal 180, right? So if we take 180 and subtract 123, now we know this angle is 57. Do you have an AirPod or something in, Lyndon?
No.
Because I said your name several times and you said it no, I was just making sure. Okay. So now the other one we need to find is the measure of angle RQT. So we need to find the measure of RQT. So we're looking for this one. Everybody clear? All right. So we can't subtract from 180 because we don't know what this one is, right? We don't really have any other way to find it if we don't know what this one is. Do we have a way to find what the measure of this angle is? Okay. What do you think? Can you tell me?
Yes, I think that the whole circle equals 360. You should subtract between 8 from 360.
Nope. What do you think, Kendall? Can you tell me a way to find the measure of this angle? Let's look at this angle is, look at the endpoints of this angle. The endpoints of this angle, so this is an inscribed angle, its center, its vertex is on the circle. Its endpoints are the same as this arc we just marked. Right, so this is the arc that intercepts this angle. So what is the measure of this angle going to be, AJ? What is the measure of this angle going to be? So you got to stay focused with me, buddy. So it's hard to learn this stuff if you're zoning in and out, okay? Corey? Nope, it's not 90. That would be if it was a triangle, right? Charlotte?
You divide the 228 by 2.
You do. So this arc has the same endpoints as our angle. So it is intercepting this inscribed angle. So that's going to be 114. So now we know that this angle and this angle are supplementary, the rule we just learned. So we're going to subtract 114 from 180, and now we know that angle measures 66. It's really hard to learn this stuff, guys, if you're not staying zoned in. I know it's not the most exciting stuff, but I'm literally, it's like you saying the sky is blue, and 10 minutes later asking what color the sky is and not being able to tell me, because you're losing focus, right? I'm literally telling you what you're looking for, and you got to stay zoned in. It's too hard if you don't. And I know sometimes it's hard to stay focused as well. You got to make a concerted effort, though. All right, any questions on this one? All right, so let's look at the last one. Let's go to mark the given information. Arc QR is 76 degrees. Arc QRT is 39 degrees. They're asking us to find the measure of angle SRT, so that's this one. And they're asking us to find the measure of angle RQS, which is this one. We're going to start with the measure of angle SRT. All right, so hopefully you're noticing this looks like this, right? So this is a diameter. This is an inscribed triangle, an inscribed angle where the endpoints are on the diameter. So look at this one. It's an inscribed triangle, it's inscribed angle here, and its endpoints are on the diameter. That's 180 degrees, right? What's half of the 180?
9.
Right, so now we know that this is a right angle. Hopefully your right angle looks more like a right angle than mine does, but you get the gist, right? So the whole thing is 90 and this is 39. We just subtract the 39 from 90 and now we know that the measure of angle SRT is 51 degrees.
One question.
Yes.
So, since you got the 51, would you multiply that by 2 to get the RQS?
No. RQS is not across. It's not an arc across from that angle, right?
Like a random.
So I'm gonna be honest. There's a bunch of ways to do this second part. I'm gonna just show you the way that taught that at me. We're looking for an inscribed angle here. If I know what this arc measures, I can take half of it and find that. Does that make sense, Kendall? So can anybody think of a way for me to find the measure of this arc? How can I find the measure of that arc? Tarlin?
If we divide the 76 by 2 to get that angle,
Well, that angle doesn't really tell us anything about this arc, right? Let's look.
The QT and the R, like that's a cross. Oh, no.
It is. That is one way to do it. That's not the way I was thinking, but you're right. You could double this and get this arc, double this and get this arc. But what were you thinking, Dominic?
I was thinking sometimes I learn sometimes you get the right side of it, just add 76 and the 180 to the rest.
That's just kind of the same way that Dominic was saying. So I was thinking, what if we just take, since this is the diameter, isn't this also 180? What if we subtract the 76 from 180 and we get 104? And well, we are kind of going for the easy way, right? But you guys were on the right track, and that's the thing with geometry. What's the thing with any math, especially this geometry? I actually worked this problem, both of these problems, different ways. And I thought, wait, I really want to focus on the new rules we just talked about the page before, but I was using old rules, and you can do that. Right, so if we take the 180, now we know that this is 104, 180 minus 76, and if we divide 104 by 2, now we know that that angle is 52. So you guys were on the right track. There's no wrong way to do that. That was exactly right. This would be 78. This would be 102. Add all three of those together and subtract from 360. Then you would still get 104, and then you'd take half, right? We did a little bit less math. So really with the calculator, is it a big deal? No, it is not.
Thank you for giving us a good question.
You're so welcome, Shara. Thank you for cleaning up and trying to stay focused.
Why don't you use that mic?
It's not a mic. It's a microphone for recording.
Like every